So hi everyone. I'm sure there's some familiar faces in the room, but you're all I can only see the backs of heads right now. So welcome to the session and thank you for joining us. My name is Zoe Coull. I'm the CEO of Ice Dragon Corrosion based in Toronto. And we're going to go through a little bit about how corrosion impacts the mining sector. Most of this presentation is giving you case studies. So talking through projects that we've done previously and sort of getting you a bit of a flavor of what corrosion engineers do within the mining space. So I usually start these types of presentations off by talking about the sort of higher view of corrosion and why it's important. I'd like to give you a quick introduction to Ice Dragon as well, just so you kind of know who we are and what we do, and then we'll jump right into it. So what problem do we address? Sometimes I feel like when I walk onto a mine site or the process plant or underground, it's a little bit like opening a corrosion textbook because we see all kinds of technical challenges with respect to corrosion, from stress corrosion cracking, issues with pitting, atmospheric attack, erosion corrosion, and different types of assets being impacted from piping, structures, like vessels, all kinds of things that we look at. So the industry itself deals with a lot of different technical challenges. However, we often find that if we go in and we address the technical challenge on its own, we're really only getting to half of the issue. Because of course, whenever you're working with an organization, there's a people aspect to it as well. So when I say that, I mean that sometimes corrosion is not included as standard in maintenance programs or asset management, asset integrity programs, which might be a little bit different to what you just heard from the oil and gas sector, where it is much more regulated. So really, yes.
Sorry, may I just interrupt?
Yes.
I don't know if it's on purpose, but you're not in full screen.
Oh, no, I wasn't in full screen on purpose, but I can make it full screen.
Up to you, actually.
There you go. Is that better?
Yes.
Okay, sounds good. Yeah. No, now it's not working. There we are. Okay, so why is corrosion important? Well, asset failure from corrosion, unfortunately, within the mining sector, has been associated with catastrophic failures of assets, been a root cause of catastrophic failures, and in some cases, actually fatalities. So that picture at the top there is a ship loader for an iron ore uh, loading facility in Chile. So this was about, I think, maybe 6 years ago now, where the ship loader itself collapsed because of corrosion of the supporting cables. And unfortunately, they lost the operator that morning. So from a very sort of personal perspective, this is really why I got involved in the field in the first place. So significant safety hazards. We also see very significant financial hazards. I'm sure everyone's seen the sort of cost of corrosion. I can't remember the amount now. Trillions and trillions of dollars are spent every year on direct costs of corrosion globally. When we look at the impact to some of our clients, this can be in the form of increased maintenance costs. So depending on the severity of the corrosion, it could be costing them 1 million a year, 10 to 10 million a year, I think was the highest that we've seen. But we also have issues with unscheduled downtime of our equipment, which of course can also cause financial losses as well. We also have issues where we don't have assets lasting as long. And also for some of our clients, the loss of asset availability is a really, really big metric. So I'm going to talk to you a little bit later about the project that we're doing with the Canadian Navy and how corrosion is impacting the availability of our ships and our ability to complete missions. Corrosion is also impacts environment because of discharge events and failures of various different assets. The photo down there is a slurry pipeline that pitted through and caused a spillage of I think it was tailings material from a mine into the local environment. Corrosion can also, because of all these things, have an impact on community relations. And actually, if you're working in a site that has a lot of corrosion and things don't look nice, it actually can lower the morale of the team and also impacts shareholder confidence in the company as well. So there are all these kind of cascading effects that corrosion can have. So that's why Ice Dragon exists. So we've been in operation since 2016. We're actually coming up on our 10th anniversary here. We're a team of 19 people, including our lovely interns from the Correct program too. We're based in Toronto. That's where we have our head office, but we have a team sitting in Ottawa, one in Halifax, and one person, Chidi, all by himself over in Victoria right now that we're hoping to expand. So we do have people sitting in with our clients across the country as well. So what do? We don't just do the corrosion engineering. We actually look at a holistic approach to managing corrosion risk for our clients, and we create these structured risk management programs. So for those of you who've read, you'd have to go back to 2016 to read the NACE impact report. It actually sort of maps out the best practices from about 240 odd companies around how do we manage corrosion, not just from a technical perspective, but pulling into consideration the people aspect and the management and the business side of things too. So I'd recommend that you go grab that and read it if you haven't done so already. But we started off using the sort of best practices in that, and we've created a very sort of tested now. It's a tested method of creating these corrosion risk management programs for mining. But of course, at the core of all of this is still the corrosion engineering piece, the risk identification and assessment. We do material selection, coating specification, cathodic protection inhibitors, all of those good things that you're hearing about, I'm sure. And these programs are very much driven by ensuring that we've got the right data as well. So here we are. We either work from the office here in Toronto, or we're embedded with our clients essentially to create and implement these programs. So what sort of things do we work on? I've kind of split this up into looking at different stages of the project. So we'll start off by looking at the impact that corrosion engineers can have in the design stage, and this is our favorite stage actually, because this is where we can make the biggest difference. So the first one I've got here is the Good Canadian project. This is a potash mine that's being built out in Saskatchewan by BHP. So of course, when you're mining potash, essentially you're mining salt. So luckily for us, the client in this case was a bit nervous because this was the first time that they'd actually designed and built a potash mine. So they were aware that corrosion is going to be an issue. So they actually had us come in and look at everything. We looked at all of the assets for this project, underground and in the process plant. We looked that, yeah, there's another good thing about being a corrosion engineer. You get to work with all the other engineering disciplines, the structural, the civil, the mechanical, the electrical. But we looked at the entire design and did a risk assessment for corrosion. Using that sort of risk assessment approach, we were then able to prioritize where we thought the client should spend their money. Which pieces on this list, which actions on this list are going to make the most impact long term. So we also created corrosion models to help us make some of those decisions that the operational teams will be able to use as well once they get moving. So we did all of this with it, so pure engineering in this project, and then we actually moved into working with their operational readiness team. So these teams look at how do we set up, for example, our maintenance programs? How do we make sure we've got the right skilled people in the right roles. So they do all of this prep work before the operation is commissioned and starts working, so that the teams are ready to hit the ground running. So we worked with them actually to create their overarching asset integrity program for the entire site. And we're hoping to continue working with the site as it's built, so that they have the corrosion support that they need, because this particular asset has to reach 70 years of life, which from a mining salt perspective is actually quite tricky to achieve. This was a similar one. This is a gold mine up in Nunavut. So this was about 9 years ago. We were involved in the design of this plant. The client in this particular case, it wasn't that they were mining salt, but the process water, because of the recycling, was actually predicted to reach about 8,000 ppm of chlorides. Actually, what we're seeing in process now is about 3,000. We had very little time. They brought us in at the end of the design. We had very little time, very little budget to jump into this project and make significant changes to the design. But we were able to do some good things with the structural steel, the concrete, the tanks, the piping, and also with their filter press. And we're actually seeing we're kind of monitoring some of these now. We're embedded in this site. So it's kind of cool to see the design that you put together in practice. Just to give you an example, this is one of the projects that we were able to do with them. We tend to find that large engineering companies do more of a cut and paste approach when it comes to writing coating specifications. There's not significant research into what the right coating should be. They often rely quite heavily on vendors. In this particular case, knowing that the whole plant was using salt water, so they're using this to wash structures down as well, we were able to get in and actually put a marine coating on the steel, which is working very, very well. We were also able to support them during construction with QA/QC and making sure that we had compliance with touch-ups. So when things are constructed, you'll end up with small locations that are not coated, that need to be touched up by the contractor, and ensuring like little things like that get sorted out early is actually very important to the overall longevity of the structures. So we've got this better coating in place. It's performing much better than it would have if they just used their standard epoxy. And now we actually also do regular visual inspections on their structural steel as well. So we have a program in place for maintenance and inspection. The other cool thing that we did with this project, we helped to design the concrete for durability. So when I'm telling you that there's a lot of salt in the water, that white stuff on the floor where my friend John is walking, that's actually crystallized salt, just to give you a sort of insight into how aggressive these environments can become. So with this one, we made some changes to the concrete mix design to reduce the diffusion rate of chlorides into the concrete. We've also got embedded probes actually in some of the locations in the floor here that are helping us to measure corrosion over time. We're inputting that information and information from cores into a service life model, and we're actually tracking that the concrete that we've put in is performing as we expected. It's the changes that we've made we're not going to quite get to the end of service life, I don't think, with the changes that we've made, but we doubled the lifespan of the concrete, so it can really make a big influence on how these plants operate if you can get in at the design stage. I wanted to give you a few examples of how we support operating teams. So when the plant is built, and often we get called in because of issues like no one thought about corrosion in design, so now they're stuck with it. It's become a bit of a legacy issue, or things have changed within the operating and the operations within the process itself and made it more aggressive. So that's kind of where we get involved. But this is that same gold mine. that I showed you before, the one up in Nunavut. Yeah, I've got the very close to the North Pole. It's very, very far. But what we're doing here, we were able to, as I said, to make some good impact in the design stage. But we've actually had an ICE team embedded at this site to provide immediate technical support since I think since the second year they were operating, and we're actually creating this full corrosion risk management program for them. It's actually already been implemented, and it's currently being sustained. So then what we found was that because we were sort of able to embed the corrosion piece in at this site, we've been talking to their corporate teams, and we're actually supporting their asset integrity, asset management teams to create full asset integrity programs where corrosion kind of sits. It sits throughout all the disciplines. They're using a lot of the lessons learned from this site to take those best practices and take them across the company, which is very, very cool. This was an interesting project too. So this was a project that was designed, it was built, and then they called me in almost as soon as they started to commission it because things were failing from corrosion. So if anyone ever tells you, oh, corrosion is this slow thing that we kind of don't worry about it, it's a slow thing, it can be extremely rapid. So this site, they were trying to commission it. They ended up with multiple massive tanks and thickeners that were made out of stainless steel. They were leaking. And they leaked before they even got this place up and running, like within a year. So they had extremely poor quality water that no one had assessed. They also had not assessed the corrosivity of the ore body itself. So what you're seeing at the end of this kind of conveyor here is this big stockpile. The water runoff from that stockpile, and I was involved in this project for about 6 or 7 years. And in one instance, we actually measured that water pH is about 2, which obviously very acidic. So this hadn't been taken into account in the design. They had underneath here, you can't see it, but there's a galvanized steel tunnel that was rapidly corroding away. We've got all this steel. This is the conveyor from the crusher to the stockpile, covered in dust. It's a very, very humid, warm environment. We had lots and lots of issues with this. And then we had issues within the water as well. We had widespread microbially influenced corrosion. So this is actually a cutout from one of those tanks that I mentioned through a weld. It's a section through a weld. So you can see how aggressive the mick was at this site. And interestingly, when I was on site talking to them about mick, no one actually believed me that that was a thing. So the level of awareness with some of our clients around corrosion mechanisms, it can be low. So a lot of what we do is actually increasing awareness of corrosion. We actually create training programs and things like that too. So this was an interesting one. This one actually also ended up with a full CMP that the client created a team. I think they ended up with about 20, 25 people sorting out corrosion at this site by the time that we left. Okay, and then the last one that I want to talk to you about on the operations side is a very, very interesting project. So we've been engaged with the Canadian Navy since for the last 2.5 years. So I don't know if any of you are kind of following what's going on in the news with our Navy right now, but we're waiting for new ships. We're waiting for our new combat vessels, and unfortunately, the delivery of these vessels is very delayed. So at the moment, the Navy is we've got our frigates that are combat vessels that you see here, the Halifax class. And we actually have to extend their service life beyond their intentional design life. So, of course, you've got steel, you've got seawater, you've got an underfunded military. So we are tackling huge issues with corrosion with these vessels. The good news is that we are in the process of developing and implementing a full corrosion management program for the Navy for these vessels. And it's just about to start really, really ramping up. So we've got a very good structure, as you've seen, with our corrosion management programs. The core of that is helping them to fix some of the issues that they're seeing. But this one's extremely interesting because the organization itself is extremely complex. Lots of different stakeholder groups with all different types of needs. And we're finding it's actually less about the corrosion, the technical side of things, and more about how do you manage people, change management, and that sort of thing. So very interesting project. I've got a few more here. I don't know how I'm doing for time. Let me just see here. I might just go through these quickly because there are a few at the end that I want to talk to you about where we get into research as well. When we're looking at specific assets, obviously it's very important to collect the right data and so that we can come up with the right solution. So a lot of what we do when we're on site is actually collecting the right data. So looking at visual inspections, NDT inspections, uh, sometimes we also use the external vendors to come in and do specialized NDT as well, but the collection of those data is really important. And I think that was the main point I was trying to make with this slide. This particular site couldn't collect the data because they couldn't see what was going on in this particular instance. So if you can't actually see something to see the issue, then they were kind of under the false impression that everything was fine. So making sure you go and really look at things and collect the right data is important. This is just to sort of show you again the impact of doing it right from design. These are carbon in leach tanks, so part of a gold mine process, and the client made the decision not to line them. And again, in this case, the slurry inside was abrasive. It was also full of chlorides. And these tanks started to pit within about a year and a half of bringing them online. And so we did a little analysis of how much that actually cost them, which they didn't actually really like very much because it was basically saying you should have done this right the first time, you should have listened to us. But it makes a good story. It makes a good case. You can see that it's costing them 4 times as much if you kind of put things in retroactively. Yeah, so this is a copper mine. So this is a section of a water conveyance line that was being used to pump water to a mine site. Very, very arid environment. So they were actually using poor quality water. And not all of the pipeline for some reason was actually lined. And they ended up with mick again on the inside of this. And really the point I wanted to make with this one is it's very, very important to understand if you're using water in your process, it's very important to understand what that water quality is and what the corrosion risk associated with it are. We often get surprised clients saying, oh, but it's only water, so it's probably fine. It is not probably fine. You really need to pay attention to the water quality in your operation. We also get involved with looking at flood protection systems as well. This is a coal terminal out west. So here the client had an impressed current flood protection system on all of the submerged structures for this port. But no one had looked at it in a few years. No one was quite sure it was working. It was very antiquated. So they had us come in to review it, and we recommended ripping the whole thing out and just redesigned them a nice new galvanic anode system, which was lower tech, required lower input from their team. So we designed that, we supported them through construction, we commissioned it, and now every year we get to go out and do an annual inspection, which is quite a nice little trip. I did want to do like a few slides here on some of the stuff that we've been doing that involve research, because sometimes you think, oh, consultants aren't necessarily doing research. We don't get many of these projects, but we've got a few interesting ones. This was actually for another gold mine in Canada, where the client realized that the rock bolts, these things down here in the corner, these are what stabilize the walls underground. They're usually combined with a mesh that goes over the top. And essentially you're providing structural integrity to the walls, which is quite good if you're underground, because you don't want walls falling on you. But anyway, this client was noticing that they do pull tests on these rock bolts. They pull them out of the wall to test their strength periodically. And they noticed that they really weren't getting the strength they were expecting. Some of these bolts were coming out looking very corroded. Turns out that they had very aggressive groundwater in this location. So we actually developed a full testing program, both in the field and in the lab, to allow them to figure out, first of all, what would be the best rock bolt type. We had many different rock bolts in the program. And also to understand when they should be thinking about replacing them and how often they should be testing them. So again, that idea of collecting really, really good data to inform your decisions. And of course, we continue to support them here as the mine expands so that we make sure that we're keeping an eye on the exposure conditions. This was another one that I did quite a long time ago now, but it was a global research project. So the UN introduced a test for making sure that cargo ship owners could test the corrosivity of any bulk cargo that was going in their holds. Unfortunately, they just sort of, again, cut and paste a test that was used for liquid. It didn't really have a very good track record for bulk cargoes. So what the mining industry did is they formed a sort of multi-stakeholder international, I guess, conglomerate to try and figure out how we could move forward with this mandatory test. So the ICE team, we acted as the technical director for the entire program. So we had Australia, Europe, Canada. We had different mining associations involved. We had 10 mining companies involved in the program. And what we did is we carried out corrosion testing of this UN regulation test and provided recommendations for changes to the test. It was quite exciting because I got to go to the International Maritime Organization, which is what you see here on the right, to represent Canada. And we actually managed to achieve full alignment from all the member countries. And then we were able to ratify changes to the test to make it more suitable. So that was kind of an interesting one. That one, again, there was a lot of technical work, but it was mostly stakeholder management, funnily enough. We've also been involved in doing some research with NRC. So we've got all these steel bridges across the country. Some 1/3 of them are not doing so great. They've got structural or functional deficiencies, or they're nearing the end of their life. So we've actually partnered with NRC to carry out a national survey with bridge owners to figure out where they need support with respect to technical support, coating selection, coating testing, QA/QC, and also to understand how they're making decisions about the maintenance approaches for their bridges, given that we have very limited budgets in most of our municipalities. So we're in the process of using some of this information that we've collected from them to define future research programs through NRC. So that was quite an interesting one too. And then in terms of like tech, we do have a project right now where we're working with an image analysis software company who are training their AI to detect corrosion and corrosion staining on vessels in the Navy. So we're providing them with the corrosion engineering input to help teach their algorithms to recognize corrosion. And the exciting thing here is that we're going to try and embed this tool into the programs that we're creating for the Navy as well. So I think that's the last one. Yeah. So I was just trying to give you a bit of a flavor of some of the different types of projects that we get involved in, and the sort of I don't know, like I was just hoping to sort of give you a good stretch of different things to think about and some examples to consider.